Hi, I'm covering section 2.3 today, functions and relations. So first we're going to go over some of the definitions that we need to know in order to solve the problems in this section. The first one is the first objective of this section is determine whether a relation is a function or not. So first, let's go through the definition of a relation. A set of ordered pairs x comma y is called a relation in x and y. So if you collect, for example, if you collect some ordered pairs and put them in the set, it's called a relation. So I'm going to just write an example here. So for example, for relation, so I have collection of some ordered pairs, 1, comma 2, 3, comma 4, and then 5, comma 4. So this is an example for a relation. So we have three set of ordered pairs. So the first value represents x, the second value represents the y value. So this is x, this is y. This is x, y, x, y. So this is an example for a relation. So the next one, if you go to the next definition of a function, function means like if the every x has a function itself is a relation in which every x has a unique y. In other words, if any of the x repeats, then it's not a function. So let's look at this example here. So I have one is in if you look at the x values, none of the x are repeated. So that means this is a function. So this example is a function. However, the y can be repeated. That's why I put the y value, same value here. The y value can be repeated, but the yx cannot be repeated. So the function is every x has a unique y value. So if you collect all the x in the function, then it's called the x value. So set of all x values are called the domain. So in this example, so for example, this example 1, 3, and 5 is the domain. And the range means the set of all y values are called the range. So in this example, we have 2 and 4, and 4 repeats, we don't have to write again. So this is the definition that we need to know in order to go through the problems in the sections. So I'm going to go over problem 1, 2, and 3. So I'm going to erase this. So if you want to check if the graph is a function or not, we are going to use the vertical line test. So this is the vertical line test. What it says is a graph defines y as a function of f if no vertical line intersects the graph in more than one point. So for example, so let's take the first problem. We have a circle. So draw a vertical line through the circle. So I'm drawing a vertical line through the circle and see how many points it intersects the graph, the circle. So it intersects at this point and at this point. But the definition says it's a function in no more than one point. So it cannot intersect more than one point. That means this is not a function. So let's look at problem number 2. So in this one, I'm going to draw a vertical line through the graph, and I'm seeing it's intersecting exactly one point. So it is a function. So what that means is the x value does not repeat. That's what it means. Here, in the first problem, x value repeats. That's why it's not a function. Second, it doesn't. And look at the third problem. I have these 2 points or points on the graph. So if I draw a line through this graph, it's intersecting at 2 points. So this is the front point, this is 1 point. So this is not a function. Okay. So that's how you identify if the given graphs or functions are not. So let's move on to the next problem. Okay. So next we are going to go over number 4. Evaluate the function f of x equals 2x squared minus 3x plus 1 for the given values of x. So first we are going to find f of -3. What that means is you have to plug in -3 for x. So let's put -3 for wherever the x comes. So we get 2 times -3 squared is +9. -3 times -3 is +9 plus 1. So when you add them, we get 28. So that is the answer for part A. So same thing we are going to do for part B. We are going to plug in square root of 2 wherever the x comes. So square root of 2 squared minus 3 times square root of 2 plus 1. And square root of 2 squared is +2. So 3 square root of 2 plus 1. So combine the like terms. 2 times 2 is 4 plus 1 is 5. So it's 5 minus 3 times square root of 2. In part C, we don't have a number. However, we have a letter A. So it doesn't matter. So you have to plug in A for x. So we get 2a squared minus 3a plus 1. So there are no more identical terms or the like terms. So this is going to be our answer. So the next one, problem D, same thing. We are going to plug in 3 plus z for x. So I'm going to use different color here. So it's going to be 3 plus z. 3 plus z. So what happens is 3 plus z square means you can expand this like 3 plus z times 3 plus z. Minus distribute the -3, so we get -9 minus z plus 1. So that is now when you expand 3, when you use the FOIL, 3 times 3 is 9. 3z plus 3z plus z squared minus 9 minus 3z plus 1, and distribute and collect the like terms. So we get 18 plus 12z, 6z, the 3z plus 3z is 6z plus 2z squared minus 9 minus 3z plus 1. Now combine the like terms, so we get 2z squared, 12z minus 3z is 9z. We combine these two. And 18 minus 9 is 9, 9 plus 1 is 10. So basically, I just grouped all the like terms. So we get the answer. Okay. Okay, so let's move on to the next one. I'm going to do this. So, okay, so let's go to number 5. So number 5, we have the same thing. We are going to evaluate g of x equals square root of 6 minus 2x for the given value of x. So g of 3, that means you have to plug in 3 for x here. So we get 6 minus 6, which is square root of 0, is going to be 0. And then plug in 4 for x. So we are getting 6 minus 8, which is negative number. If you have a negative inside the square root, it's basically an imaginary number. So it is undefined or imaginary. Next one, plug in negative 4 for x. So we get square root of 14. And this is going to be square root of 6 minus 2 times 2w. We don't know the value of w, so we are good. So you just put, 2w, not z. For w. 6 minus 4w. So this is the answer. Okay. Okay, so next we are going to determine x and y intercepts of a function for the given function. So let's look at the next problems. Okay, so we're going to identify the x and the y intercepts of a function. So given a function, the x-intercepts are the real equations to the, real solutions to the equation f of x equal to 0. So to find the x-intercept, we have to make y equal to 0. To find the y-intercept, we have to make x equal to 0. So let's find the x-intercept by making y equal to 0. So y is nothing but f of x. So if I put x squared minus 4 equal to 0, or x squared equal to 4, move the x equal. Then to find the x, it's going to be, x is going to be plus or minus square root of 4, which is going to be plus or minus 2. So this gives us the x-intercepts are 2, 0 and negative 2, 0. So to find the y-intercept, make x equal to 0. So when I put x equal to 0, y is going to be 0 minus 4, which is negative 4. So this gives y-intercept as 0, negative 4. So these are the solutions, intercepts for this problem. So number 7, let's find the x-intercept by making y equal to 0. Y means we have to make this equal to g of x equal to 0. So 3 minus absolute value of x equal to 0. So let's move the 3 to the other side. So subtract 3 both sides. So we get negative absolute value of x equal to negative 3. So when you cancel the absolute negative on both sides, we get absolute value of x equal to 3, or which gives, so absolute value of x equal to, I'm so sorry. I'm going to redo again. So we have g of x equal to 0. So we get 3 minus absolute value of x equal to 0. So when you subtract 3 both sides, we get absolute value of x equal to 3. That means x is 3 or negative 3. So the x-intercepts are 3, 0, and negative 3, 0. To find the y-intercept, we have to make x equal to 0. So that means y is going to be just 3. So the y-intercept is 0, 3. And the last one, we have h of x. Let's find the x-intercept by making y equal to 0, but that means this h of x is 0. So 2 minus square root of x is going to be 0. Or when you move the 2 to the other side, or the square root of x, you can move the square root of x. So we get 2 equals square root of x. So the x-intercept is, now we have to find the x, sorry. So we have to square both sides to get the x by itself, square both sides. So we get x equals 4. So the x-intercept is 4, 0. And the y-intercept is, you have to make x equal to 0. So it's going to be 2 minus 0, which is just 2. So the y-intercept is 0, 2. So that's the rule. To find the x-intercept, make y equal to 0. To find the y-intercept, make x equal to 0. Okay, so the next objective in this section is we are going to determine domain and range of a function. And then the last objective is we are going to interpret the function graphically. So let's go to the next objective. I'm going to put this. Okay. Determine domain and range of a function. So we just learned domain means the x values and the range is the y value. So the x is the domain and y is the range. So now in this graph, number 9, we are going to find both x and y. So determine the domain and the range for the function. Number 9, it's a parabola. And if you look here, there are arrows on the top. That means the graph grows infinitely on both sides. So we have to find the domain. So since it goes to this side infinity, this side infinity, so this is going to go positive infinity. This is going to grow up to negative infinity on this x-axis. So the domain is going to be negative infinity to positive infinity because the graph grows both sides infinitely. And look at the range. The range is the y value. So this is the y value. This is what we have to consider. So the graph starts right here. The graph starts at 2. And it goes all the way up to positive infinity. So the range is going to be 2, infinity. I have to do one more thing. This is closed interval 2, infinity, because the point 2 is included, so we have to put the closed brackets here. Next, for the domain, for the next problem, so let's look at the domain. Okay, now the domain is the x value. So the graph started, there are two pieces here. The first one is starting from negative infinity, right? And it stops at, this is the value of 0. However, again, the graph starts at 0 with closed. This is open. However, this is not open. That means this is included. This point is included. And it starts from 0 and it goes all the way up to positive infinity. So that means the domain is going to be negative infinity to positive infinity. Next, let's look at the range. The range is The graph starts from this point because the range is the y value. So the graph starts at -10. So I'm going to put -10 and it's closed, it's included. And where does it go? So the graph goes all the way up to positive infinity. Okay. Okay, so let's go to the next one. Next, number 11. Again, the same thing. We have to find the domain and the range. So let's look at the domain. So it starts from it starts from negative infinity because we see the arrow, and it stops at +1. This is 1 because we are looking at the x values. However, this is open, but look at the second piece, it's closed, so that means the 1 is included. And however, it stops at 4. This is the point 4, so it stops at 4 and 4 is inclusive, so we have to put the closed bracket. So next we are going to look at the range. The range is the y value here. So the y is, if you look at this one, this is one straight line and this value is 1. So all the range for this whole line is going to be just 1. So we're going to put just 1. There are two sets or two intervals for the domain here. And the next one starts from 2 and it stops at 8. So it's going to be 2, the interval 2, 8, both included. And you have to put, when you have more than one interval or the set, you have to put the union symbol. Okay, because this is a combination of both set 1 and the interval 2, infinity. Let's look at the next one. The domain is the x value and the function stops here, so it stops at -2 and it goes all the way up to positive infinity. So the domain is going to be -2, infinity. And the range is, if you look at the arrow, that means it's going to go down. That's what it means. So it's going up to negative infinity. So we put the negative infinity. And where does it stop? It stops at 4. So it's going to be negative infinity, 4. Okay. So let's move on to the next one. Next problem we have. We have to interpret a function graphically. Okay. Okay, so use the graph to answer the following. So first one, we have to find f of -3. Okay. So -3. So that means this -3 is the x value. So let's go to x equals -3. So this is -3. Where does it meet the graph? It's meeting the graph at -3. So that means this means f of -3 is going to be -3. Okay. Next, f of 0. So let's look at 0. So x value 0 is right here. Where does it meet the graph? The graph meets at this point, which is 2. So that means f of 0 is going to be 2. Okay. Next, find all the x value for which f of x is -1. This value is nothing but y value. So we have to go to y equals -1. So I went, this is y is -1. Okay. And where does it meet the graph? This is the point where x is -1. So we are finding the point where y is -1. So x is going to be, we are getting the x value. It's the opposite. Okay. So the x value is going to be -1. So last, the part D, we have to find x for which f of x equal to 1. So that means this y is going to be 1. So I'm going this is y is 1. Where does it meet the graph? It's meeting at this point. However, this is open. That means this is not included. So the only point included is 1. This one, which is 2. This is 2. So x is going to be 2. Okay. Next, we have to find the x-intercept. What do we mean by x-intercept? It's the point where it crosses the x-axis. Look at the graph. Do we see any graph on the x-axis? The graph doesn't touch the x-axis at all. So that means there is no x-intercept. And the last problem, determine the y-intercept. Y-intercept is the point where it crosses the y-axis. So this is the graph, this is the point where it crosses the y-axis, which is the point 0, 2. So the y-intercept is going to be 0, 2. So in this section, we learned how to identify a function from the graph. In the graph, if you have to find if the graph is a function or not, we have to use the vertical line test. And second objective, we learn how to deter the function notation, that is evaluating the function. So that is what we learned in the second objective. We have to plug in the numbers or the variables, whatever is given for x in the given function. And the third objectives, we learn how to identify the x and the y-intercepts. To find the x-intercepts, we have to make y equal to 0. To find the y-intercept, we have to make x equal to 0. And the next objective, we learn how to find the domain and the range of the function. So the domain means x values, the range is the y value. And the last one, we learned how to interpret a function. So that's the end of this section. So I will see you in the next one. Okay, until then, bye.